All right, this lab brings together a whole lot of things that you've been learning up to this point. What you're going to do today is you're going to receive a certain amount of sodium hydroxide. It's going to be a teaspoon. And I'm going to have you determine the mass of that so that then you can determine how many moles are in that of sodium hydroxide are in that teaspoon. I'm also going to give you an amount of water. It's roughly going to be about 100 milliliters, but I'm not going to measure out the volume. I'm just going to roughly give you 100 milliliters, and then I'm going to have you do some things to calculate the percent sodium hydroxide by mass, as well as the molarity and the molality of the sodium hydroxide solution. Now, there's a couple other things that we're adding in this module. One of those is we're bringing in the idea of freezing point depression and boiling point elevation. Now, for both of those, you're going to need to use your molality as your concentration. We're also going to kind of go backwards a little bit. Last week, what you guys did was you titrated a solution of ammonia with a known concentration of acetic acid. So we're going to do another titration today, but this one's going to be with a strong acid and a strong base. Your strong acid will be hydrochloric acid, and your strong base will be the sodium hydroxide solution that you're going to make up. So the key to moving between molarity and molality is knowing the density of the solution. Also, if you want to be able to go from percent composition to molarity, you need to know the density of the solution. So we're also going to calculate the density of our solution here. Sodium hydroxide as well as hydrochloric acid. These are both caustic, so you're going to be wearing your gloves and your safety glasses throughout this lab. Here is a picture of a map that I'm going to encourage you to think through. And by the way, I think it would be a really good idea if you commit this map to memory so that you can draw it out. It will be a huge help to you as you navigate from molarity to molality, or if you're trying to move from percent by mass to percent by mass to molarity. And so we'll start off by determining the density early, and then we'll go from there. Okay, so first off, I'm going to use this sheet to guide you through the bringing it all together lab. So you're going to use a scale. You're going to determine the mass of your sodium hydroxide solution, and then you're going to calculate the moles of that. Let me show you what's you're familiar with doing it, but let me show you again kind of how we're going to walk through that. Okay, so I'm going to give you a teaspoon of sodium hydroxide, and you're going to put it into a cup. Now, I've already pre-weighed the mass of that cup because I want to be able to know how many grams of sodium hydroxide I have so that after I add it to it, then I can just go weigh my cup and subtract out the mass of the cup. Along that line, you're also going to be determining the density of that solution, and you're going to be doing that in a 50 milliliter volumetric flask. So you're going to want to determine the mass of that before you add any solution to it as well so that you can determine the mass of 50 mils of solution. And then lastly, I have also weighed out the mass of a beaker that's going to hold our approximately 100 milligrams of sodium hydroxide solution. So those are the things you want to pre-weigh before you even get started. Now to the actual lab. All right, here's how we're going to do this. I'm going to give you just a teaspoon of this sodium hydroxide solution, and I'm going to have you determine its mass. So put a teaspoon, unknown mass, right into my cup. And now we're going to determine what the mass is. Okay, so whenever I weighed it with the cup and the sodium hydroxide, I came up with 9.29 grams. And so that's what would go into that box right there. The next thing you're going to want to do, you don't have to do it right in this order, but you're going to come back in a little bit and you're going to calculate the moles of sodium hydroxide. So we'll just skip that box because that's just a calculation. The next thing you want to determine is the mass of your solvent, which is going to be water in this case. So I have already determined the mass of the beaker that I'm going to put the water in. And so now I'm just going to pour approximately 100 milliliters of water into our beaker here. That's 122.76 grams for the beaker. And then I'm going to go weigh the water and see how much is in there. So like I said, I'm just going to put an approximate amount. This beaker here would hold 120 mils of water. Don't really know how much is in there. The the way they grade is not very accurate. So I'm just going to add all of that into my beaker here, and then I'm going to go determine the mass of this water. Okay, so I determined the mass of my water now. That's going to weigh 109.23 grams. So I took the mass of the water plus the cup and then subtract the mass of the beaker out of there. So we'll write that number down in here. That's going to be the mass of our water. Now we can do a simple calculation to figure out the mass of our solution, because that's going to be nothing more than the grams of sodium hydroxide plus the mass of the water. So that number right there plus this number here, in this case it's going to be 9.29 grams plus 109.23. That will give me the mass of my solution. Next thing we're going to want to do is calculate the molality and then the percent by mass of our solution. But before we get to calculate that, we're going to mix the two together. And let me mention something about that. Okay, so we're going to bring the sodium hydroxide into solution. Something about sodium hydroxide is it's very hydrophilic, so it even clumps. If you were to be able to, I don't think you can see here very well, but if I turn my camera down, you might even be able to see that it's already starting to clump a little bit around the edges in my cup. So that'll also happen whenever we just try to dissolve it into our solution. Sometimes it'll kind of clump and it's a little slow to go into solution. So what we're going to do to help that out, let me move my camera over here. See if I can get this turned off. There we go. There we go. So one of the things that we can do to help that go into solution is we're just going to put it on a stir plate, and we're going to add it slowly enough that as the bar stirs, hopefully it'll go into solution fairly easy without a lot of clumping. And our goal here is just to bring all of this sodium hydroxide into solution. Now this is going to be an exothermic reaction, so if you actually touch your beaker when you're doing it, you might notice that it warms up a little bit. And we'll talk about exothermic and endothermic reactions more whenever we get into our thermochemistry. But there we go. So I don't need to show you all of this in great detail, but just know that what I'm doing is slowly adding the sodium hydroxide. My goal is just to keep it from being too clumpy in the bottom and to bring it into solution. So as I'm trying to bring this into solution, one of the things you can see is whenever I try to dump it out, a bunch of it just stays in the cup. So what I'm going to do is I'm just going to use a pipette, and I'm going to pull some of my solution out and rinse out my cup with some of that solution. So I'm not adding any volume of water to my final solution here, but I'm just using it to rinse out my sodium hydroxide. Best I can, I want to get all of the sodium hydroxide that was in the cup out of the cup. I'm claiming that I put that much mass into my solution, and it's basically going to be that mass from which that we're going to determine our molarity. So anyway, the point is we want to get that cup clean. There we go. And keep in mind, this is a caustic solution, so even the bubbles and the little drips and things that are a part of the pipette, you don't want to be blowing those out anywhere near your face or anybody else's, because they'll burn your skin. All right, now what I have is a solution of sodium hydroxide, and I touched it. It's actually warm to the touch. And, the room is kind of cool, so it shows that it's an endothermic reaction. The next thing that I want to do is determine the density of that solution. And to do that, I have already pre-weighed this 50 ml volumetric flask at 37.25 grams. So I can determine the density of this solution by putting 50 milliliters of it in here and then weighing that 50 milliliters. Because I know that it's going to be 50 mils because it's a 50 ml volumetric flask. And what I don't know is how many grams per mil. So let me go about doing that. Okay, so when I weighed that, it weighs 53.83 grams of solution. That the whole thing actually weighed 91.08, and from that I subtracted the mass of my flask, and so I come up with a mass of 53.83 grams for 50 mils. All right, so we're going to write the density of this thing down. Okay, so here I actually gave you a spot to write down the mass of your flask. I didn't do that on your other ones, but so right here, for example, mine would say 91.08 grams. The mass of the flask plus the 50 mils of solution, excuse me, this would be 37.25. This is going to be 91.08. If I subtract that out, I end up, like I said, with 53.83 grams for 50 mils of solution. And the way I calculate the density is I put that in grams per mil. So I put 53.83 on top and then 50.00 milliliters on the bottom, and that's going to give me the density of my solution. And so when I calculate that out, let me see what I come up with here. Okay, so what I come up with is a density of 1.08 grams per mil. All right, now what I can do, now that I know the density of the solution, and by the density of solution, what I mean is, I understand that we use this volumetric flask to determine the density of 50 mils, but really what we want to know is now the volume of our entire solution. So, but the density is the same between the two. I just have a known volume here. So I can take this 50 mils and pour it right back into my original. And if I want to know what the volume of that solution is, I can calculate it off of the density that I just calculated. Let me show you how we're going to do that. All right, so here's how we're going to calculate our initial volume. We know that we have a density of 1.08 grams per mil of our sodium hydroxide solution. So the mass of the solution is nothing more than the mass of the sodium hydroxide that we added to the water. But now we want to figure out what the volume of that solution is. So I know that if I add those two together, I have the mass of the solution, which is good. So if I take the mass of the solution and I use its density, I can calculate the volume. Here I do that is I have 118.52 grams of solution, and I know that there are 1.08 grams of solution for every mil. And so this allows me to convert between grams of solution to mils of solution. Now what I end up with is a volume of 109.74 mils. Unfortunately, I only have 3 significant figures here, so I'm going to say that my initial volume is 110, and I'm just going to put a point there to say that that 0 is actually significant because I have 3 significant figures there. So here, the volume of our solution now goes right there. That's where I'm going to put 110 mils. So now we have all of the measurements that we need to calculate our molarity, our molality, and our percent composition. And let me go ahead and show you how we're going to do our titration. So we're going to do our titration just like we did last week. Here's our titration burette. Instead of putting acetic acid in it like we did last week, we're going to put our 2 molar hydrochloric acid solution into that. And then we will titrate our sodium hydroxide with 2 molar hydrochloric acid. All right, so what I'm going to do is I'm going to put 5 milliliters of my sodium hydroxide solution into an empty beaker here. And from that, we're going to titrate. Actually, you're going to be using a 2 molar hydrochloric acid solution. I have a 1 molar solution here that I have it loaded with. So my volume will be twice as many mils as yours. My concentration is half. All right, so now I have 5 milliliters of my sodium hydroxide solution in the beaker. I'm going to put a stir bar in there, plus I'm going to put 2 drops of phenolphthalein, so then I know my indicator There we go. My phenolphthalein. There we go. And now, I made a note of my initial volume in my pipette here. If you were to look up there, it's at 1 milliliter. So I'm just going to add my solution to it until it goes clear. A nice little stream here. And usually when people do a titration, they do one that's really rapid to start with. They don't try to dial it in. They just want to get within like 1 mil or so. And then they go back again and do the titration when they know where it's close to uh, the, uh, the end point. So I'm just letting it run freely right now. Because I have no idea how many milliliters it's going to take. And then when it actually turns clear, I'm going to make a note of it. Now, I wasn't very precise with my volume, but I know that this is taking, now that took 19 milliliters roughly to get there. So what I would do is, now I would do this again, and I would put a fresh 5 mils in there, and I would then titrate it, and I would add 18 milliliters, watching it really closely, and then when I get to that, I would slow it down and add it drop by drop so that I can dial in far more precisely. But roughly, this took 19 milliliters of 1 molar hydrochloric acid to titrate that solution. So what we call that is a rough titration. I wouldn't even use that 19 milliliters and call it my first titration. I would do it again, and like I said, I would add 18 milliliters, and then I would add it drop by drop to get to a far more precise volume. And then I would clean that all up, and I would do it one more time and see if these two volumes are pretty close to each other. And I would average the two volumes and use that as my volume of hydrochloric acid that it took to neutralize 5 milliliters of my sodium hydroxide solution. All right, so just for maybe an idea of a sample calculations, let's say that it turned out to be 19 mils exactly. And keep in mind, I used a 1 molar solution, so my calculation will be a little different. But I would write down 19.0 milliliters of hydrochloric acid, and I got to convert that to liters, so I have 1,000 mils equals 1 liter, and then I'm going to multiply that by 1 mole, because my solution is 1 molar rather than 2 per liter, and that will give me the number of moles I have of hydrochloric acid in 19 mils. So if I do those calculations for my set, I come up with 0.019 moles of hydrochloric acid. Now that I know how many moles of hydrochloric acid it took, what I know is that I had 5 milliliters of my sodium hydroxide solution. And to neutralize our sodium hydroxide solution, 1 mole of sodium hydrochloric acid will neutralize 1 mole of sodium hydroxide. So if I want to know how many moles of sodium hydroxide were in that 5 mils, that's really simple. I just write down 0.019 moles of hydrochloric acid, and because it's a one-to-one relationship between hydrochloric acid and sodium hydroxide, this is also going to be 0.19 moles of sodium hydroxide. Now keep in mind, that's not how many moles were in our whole solution, that's how many moles were in 5 mils. And so now we'll say that I have 0.019 moles of sodium hydroxide solution in 5 milliliters, and then I got to convert that to molar. So there are 1,000 mils per liter, and so I take that number, divide that by 1,000, and that will give me the molarity of my sodium hydroxide solution. All right, so we're going to go back up and calculate our molality. We didn't do that earlier, but we might as well. So we can do our freezing point depression and boiling point elevation. So molality is the number of moles of solute divided by the kilograms of solvent. Okay, so on mine, I had a mass of 9.29 grams of sodium hydroxide, and that comes out to 2.11 let's see what that is. No, that's 0.232 moles. So that's 0.232 moles of sodium hydroxide. Now that's going to be that many moles into a a volume of my solvent, and I determined the mass of my solvent, and I wrote that up on top, and the mass of my solvent, let me look back and see what that was. That was 109.23 grams. So I'm going to say that I have 0.232 moles in 109.23 grams of solute. That's our water. And then I'm going to convert that to kilograms. So I know that 1 gram is equal to 1,000 kilograms. And so I'll multiply that out and come up with my molality. All right, so when I multiply that out, if I take 0.232 moles of sodium hydroxide, divide that by 109.23 grams of solute, that gives me 0.00212 moles per gram of solute, and I have 1,000 grams because it's in kilograms of solvent. So if I'll take that number and multiply it by 1,000, I come up with 2.12 molal, M-O-L-A-L, molal. So I'll take that 2.12, and then I'm just going to bring that down here and plug it into these equations here. So my molality is 2.12 molal for this one, and it's the same thing here. That's my molality there. Now I just need to plug in my my constants, and my I is 1 because there's only one ion in this solution, and well, actually the sodium hydroxide, there's 2 ions, so that'll be a 2 right there for that one. Anyway, that's how we're going to calculate our boiling point elevation and our freezing point depression. All right, let's hope that helped and more than it confused you. So leave this lab to you. Now whenever you come, you're going to do a quiz, and then we'll talk a little bit about this, and I'll turn you over to determine your own molality and molarity of your solutions. Have fun and be safe with it.